Today we are going to start class 10 subject physics topic 11.2. Today topic of today's lecture is 11.2. Uh, Chapter number 11 we are doing sound. Pages covered in today's lecture will be 24, 25 and 26. This topic is actually the continuation of 11.2 topic. We discussed in 11.2 characteristic of sound. We studied the characteristic of sound like loudness, on which factor loudness is depending upon. So I give you a quick review. Loudness of sound is depending upon amplitude of the vibrating body, then area of the vibrating body, distance from the vibrating body, and then we studied pitch, quality, and today and intensity, the definition of intensity. In my last lecture, I gave you the audio lecture because I couldn't share my screen. But in today's lecture, the thing is same, but we will discuss about intensity, sound intensity level, or the same thing we will discuss today. Now, the chapter number 11, sound, related to sound. Now, I give you the definition of intensity. First, I read the definition. Sound energy passing per second through a unit area head perpendicular to the direction of propagation of sound wave is called intensity of sound. This is the definition. You got to memorize this. You got to learn this by heart because this definition comes in board exam 2 marks, right? So the unit of intensity of sound, and you also mentioned that you will also mention in your definition, you will also, first of all, you will write the definition of the sound energy passing, and then you will write the definition of sound energy passing per second through a unit area held perpendicular to the direction of propagation of sound wave is called intensity of sound. And you will also, intensity is a physical quantity and can be measured accurately. It is a physical quantity. You can see this. Intensity is a physical quantity. The unit of intensity of sound is watt per square meter. You got to memorize this. The unit of intensity of sound is watt per square meter. But today's lecture, we will discuss about sound intensity level. We have discussed all these things in our previous lectures, but today's lecture, we will again discuss sound intensity level. The human ear responds to the intensities ranging from 10 raised to the power minus 12 watt per square meter to more than watt per square meter. I told you in my earlier lecture when I recorded the audio, the human ear responds to the intensity ranging from 10 raised to the power minus 12 watt per square meter. We know the unit of intensity of sound is watt per square meter, which is 10 raised to the power minus 12. This is the reference level. You always consider this reference level. Take this range of the intensity of sound as reference, 10 raised to the power minus 12 watt per square meter. And this is the upper limit, 1 watt per square meter, which is loud enough to be painful. This intensity level is very loud enough, which is painful to our ears. But this is the faintest, and this is the reference intensity level of sound. And you got to remember this because we will use this 10 to the power minus 2 watt per square meter so many times in our numericals, and we should remember this. And when we do our problems, we will memorize this faintest intensity level of sound is 10 to the power minus 12, and its unit is watt per square meter. The barely audible and the faintest intensity of sound is 10 to the power minus 12 watt per square meter, as I have already told you, because we are taking it as reference, called zero bell. This is called zero bell. Why this is called zero bell? This is after the scientist Alexander Graham Bell. This unit is called zero bell, which is after the scientist Alexander Graham Bell. Okay, the loudness of sound also depends not only on the intensity of sound. Loudness also depends upon the only the intensity of sound, but also the physical condition of the ear, how our ears are. So if our ears are good, then the intensity will be also depending upon the physical condition of it, how our ears are, whether they are defective or whether they are good in good condition. So intensity, loudness of sound is not only depending on the intensity of sound, but also on the physical condition of the ears, how our ears are good or bad, good or defective. The human ear is more sensitive to some frequencies than the others. So if I take loudness of sound, if the loudness of sound is denoted with capital L of a sound, so loudness of sound is directly proportional to the logarithm of the intensity. As you know, what does this mean? Directly proportional. What does it mean? Inversely proportional. I have already told you in my ninth class what is directly proportional. I again repeat. I repeat for you. Directly one thing increase, other also increase. This is called directly proportional. If one thing decrease, other also decrease. This is also called that directly proportional. For example, if you go to the shop, if you go to the shop and ask the shopkeeper, give me 4x, he will charge you the price of the, let's suppose the price of the 1x is 10 rupees. The price of the 4x will be 40 rupees. But what will happen if you increase the quantity of it? If you increase 6x, he will not charge you 40 rupees, he will charge you 60 rupees now, because you have increased the quantity. It means one quantity, if the number of quantities of eggs increased, the price will also increase. This is directly proportional. For example, if you not buy, if right now you don't buy 6x, you buy 2x. So he will not charge the price of 6x, but he will charge you 2x price, and the price of 2x will be 20 rupees. So you have decreased the quantity of eggs, the price is also decreased. This is also called directly proportional. So L is directly proportional to log I. So he's saying the loudness L of the sound is directly proportional to the logarithm of the intensity. This is I is intensity. So log is actually log. Log is actually log value, and this is not natural log. This is the base 10. But what will happen if you remove the directly proportional sign? So it will come with equal and some constant of proportionality. In this case, the constant of proportionality is k. So L is equal to k log I. So where k is the constant of proportionality, as I have already told you. This is I named this equation 11 point. I named this equation 11.1. I named this equation 11.1. Now, let L naught be the loudness of the faintest audible sound, as I have given you 10 to the minus 12 is the faintest sound. In the audible sound of the intensity I naught, and L is the loudness of an unknown sound of the intensity I. So if I replace the above equation 11.1 equation with L with replaced with L naught and I is replaced with I naught, then my equation 11.1 becomes this: L naught equals to K times log I naught. Now I named this equation 11.2, or now the next subtracting 11.2 from equation 11.1. 11.2 will be subtracted from 11.1. Then my new equation will, which after subtraction, L minus L naught equals to K times log I minus log I naught. I have subtracted 11.2 from 11.1. So if you left hand side will be subtracted, left hand side will be subtracted to left hand side, and right hand side will be subtracted to the right hand side. You got to remember this. L minus L naught is the left hand side, and K times log I minus log I naught is the my right hand side. So you should know the property of logarithm. Whenever we have subtraction sign in log, you got to remember this. You will read in 10th class book when you study the log properties. So mathematics book when you study the logarithm. So whenever you find subtraction sign, in logarithm, you replace it with log, you replaced it k times log. If you change this subtraction into the division, because this is the property of the logarithm. So k will be as it is log I over I naught. The difference L minus L naught between the loudness L of an unknown sound and then loudness L. This is the difference. L minus L naught is the difference. And that's why he's saying the difference L minus L between the loudness L is the loudness and of an unknown sound and the loudness L naught is called the intensity level of note. I am replacing this L minus L naught as intensity level because he's saying this difference L minus L naught between the loudness L of an unknown sound and the loudness L naught is called the intensity level of. So L minus L naught is, I'm going to replace this with, I'm writing this intensity level. This equation will be seen as k log I over I naught. So forget about this now because I have changed subtraction sign into the logarithmic division sign. So intensity level is equal to k log I over I naught, where k, it depends upon not only the unit of I and I naught, but also on the unit of intensity level. K is also not depending on the unit of I, the unit of k is also depending on the unit of I and I naught, and it is also depending on the intensity level. So what is going to be happen here if the intensity I of an unknown sound is 10 times greater than the intensity. So the relation between simple I and I naught is, so intensity is equal to 10 times I naught. You got to remember this. I equals to 10 times I naught. So this level is called bell. And the intensity level of sound is taken as unit called bell. The value of k becomes 1. If I put k equals to 1, then my equation 11.3 will become k. If put k equals to 1, then log I over I naught bell. This will call bell. And if I replace I with 10 times log I naught, then my equation, this is called decibel. Bell is a very large, this is very, bell is very large. When I put k is equal to 1, this will call bell. And bell is a very, very large unit of intensity level of sound. But if I consider the small unit, I already gave you the example, like kilometer is the bigger unit and meter is the smaller unit. So similarly, bell is the bigger unit of intensity level, and now I'm moving towards the smaller unit. So if I'm going to the smaller unit, that is called the decibel. So I will replace 10 log I because I is equal to 10 I naught. So that's why k value will be 10 log I over I naught dB decibel. This is called decibel. So there is a relation between bell and decibel. 10 log I over I naught is called decibel, and this is the smaller unit of intensity level of sound. So using equation 11.5, this is equation 11.5, we can construct a scale for measuring the intensity level of sound. Such a scale is known as decibel scale. Where dB stands for decibel. So bell is the bigger unit of intensity level of sound, while decibel is the smaller unit of level of sound. So the intensity level of different sound is decibel is given table 11.1. So if I consider the table 11.1, so what is going to be happen? So this is the intensity in watt per square meter. I have already told you the unit of intensity is watt per square meter, and the other unit is decibel. So we are considering watt per square meter and intensity level in decibel. Nearby jet, this table comes in the MCQ's point. This is important according to the MCQ's point of view. This table 11.1, and this table is important for the MCQ's point of view. Nearby jet airplane 10 to the power 3 intensity watt per square meter. 10 to the power 3 is watt per square meter. But if we go back to the intensity level in decibel, it will be 150. I will show you how it comes in when we do the example 11.1. Siren. Siren is 10 to the power jackhammer or fast train. Its intensity in watt per square meter is 10 to the power 1, but in decibel it's in the intensity level in decibel will be 130. But siren is 10 raised to the power 0 in watt per scale meter, but intensity level in decibel will be 120. Lawn mower 10 raised to the power minus 12 watt per square meter, and its intensity level in decibel is 100. Vacuum cleaner 10 raised to the power minus 5, so intensity level decibel is 20. Mosquito buzzing 10 raised to the power minus 8 watt per square meter, and intensity level in 40. Similarly, faintest audible sound threshold, as I gave you when we discussed the reference, you take it as reference 10 to the minus 12 watt per square meter, and its decibel level, intensity level in decibel is 0. Similarly, rustling of leaf is 10 to the power minus 11, and in decibel is 10. I will show you these two things. I will prove you in these two things when we solve the example 11.1. So you got to remember 11.1 is important according to the MCQ's point of view. Now I am moving towards example 11.1, and I will use this equation 11.5 in my example 11.1. So I will use intensity level is equal to 10 log I over I naught in decibel. I will use this in numerical example 11.1. And my example 11.1 is on page number 25. On page number 25. I read the numerical statement, calculate the intensity level of the faintest audible sound and rustling of leaves. So in this numerical, we got to find faintest audible sound or in decibel, and rustling of leaves in decibel. We need to convert these two in decibel value. I will show you rustling of leaf is 10 from minus 11 in watt per square meter, but in decibel it is 10. But our faintest audible sound threshold, 10 square, which is taken as reference, 10 square minus 12, and in intensity level in decibel is 0. Okay, so I solved the numerical on this. Calculate the intensity level of the sound faintest audible. This is faintest. So faintest audible sound is 10 to the power minus 12. So I will take it 10 to the power minus 12, and we will calculate in decibel, which will come 0. Intensity level of faintest audible sound can be calculated by substituting I equals to I naught. I will substitute I equals to I naught here in this equation. I will use in this equation, in this numerical, in this example 11.1, I will use equation 11.5, which is on page number 25. Okay, and faintest audible substitute I equal to I naught, which is 10 to the minus 12 watt per square meter in equation 11.5. Intensity level of faintest audible sound is this 10 log I over I naught. So I am putting 10 to the power minus 12 on the top, and bottom 10 to the power minus 12. So 10 to the power minus 12 will cancel with 10. This 10 to the power minus 12 will cancel with 10. This 10 to the power minus 12. So here 1 will come. So log 1, if you take log, there is a difference between log and there is a difference between ln. Ln is the natural log, and log is the log base 10. So log we will use on the calculator. So you have on calculator, you have two choices. One choice is log and one is ln. You will not use ln, you will take log log. So I will use this formula. I equals to 10 to the minus 12. I put 10 to the minus 12 and then 10 to the minus 12. This 10 to the minus 12 will cancel with this 10 to the minus 12. So log 1, if you take log 1 on calculator, so you will get 0. So 0 multiplied by 10 is 0 decibel. So I have proved intensity level of faintest audible sound in decibel is 0. So I showed you on the table here is 0 decibel. So 10 to the minus 12 in decibel is 0. Now I move towards the other part of this numerical example 11.1. 11.1, we need to find, if I go back we need to do the second B part of this numerical example 11.1, rustling of leaves. So you know rustling of leaf is 10 raised to the power, intensity level is in watt per square meter is 10 to the power minus 11. We need to convert this into decibel. How will I convert this into decibel? So you know at the intensity level of rustling of leaf is I is equal to 10 to the power minus 11 watt per square meter. Therefore, I will use the same formula. Intensity level due to the rustling of leaf equals to 10 log 10 raised to power. I will put I equals to 10 raised to the power minus 11, and in the bottom we have in the formula 10 to the power minus 12. If you take this 10 to the power minus 12 on the top, so when the bases are same, power will be added. Minus 11 plus 12, it will come 10 to the power 1. It will come 10 to the power 1. So log 10, you will again take on calculator log log, not ln log, log base 10. So log, if you take, and if you press log and then take and put 10, then you will get 1. Value is 10 log 10 is 1. So 1 multiplied by 10 is 10 decibel. So I show you in the table that rustling of leaf is has been converted into intensity level in decibel, which is 10. So rustling of leaf is 10 to the minus 11 in watt per square meter, but on decibel it is 10. It has been converted into 10. So this is end of today's lecture. So I will repeat the whole thing for you one more time. So what we discussed today, uh, we studied the definition, sound energy passing per second through a unit area held perpendicular to the direction of the propagation of sound wave is called intensity of sound. Intensity of sound is a physical quantity and can be measured accurately. The unit of intensity of sound is watt per square meter. You should know the unit of intensity of sound is watt per square meter. Then after studying this, after you got to memorize this by heart, because these definitions are very important because these come in examinations. So this definition and the unit of intensity of sound is watt per square meter. You got to remember this by heart. Next thing we studied, sound and intensity level. I told you the faintest intensity level is 10 to the power minus 12 watt per square meter, which is the reference level. So I told you loudness L of a sound is directly proportional to the logarithm of the intensity. So L is the loudness of sound. You know, we noted when we discussed previous 11.2, when we started 11.2 topic, we discussed loudness of sound is denoted with letter capital L. So L is directly proportional to log I. When we remove this directly proportional sign, then we will get K, where the K is the constant of proportionality and equal size term. Whenever we remove the directly proportional sign, it replaced with equal and some constant of proportionality. Where L naught is the L naught is the loudness of the, if I replace L with L naught and I with I naught, then my equation 11.1 becomes 11 I replace L with L naught and I naught, then L next equation will become L naught is equal to A of I naught, which is 11.2. Then I subtract 11.2 from 11.1. So our new equation will be L minus L naught K log I minus log I. I subtract this. So you know the logarithm, the property of logarithm. When we have a subtraction in the logarithm, that will be replaced in division in the logarithm. So log I over I naught. So L minus L naught, the difference between L minus L naught is I set this intensity level. So I write this K log I same as it is. The value K is not only depending on the unit of I and I naught, but also the unit of intensity level. So we have two units of intensity. One is the bigger one, and one is smaller one. Value is the bigger unit of intensity level, and there is a relation between I is equal to 10 I. You should remember this by heart. I is equal to 10 times I. Very important. So the K, I put K is equal to 1. So log I over I naught is called Bell. Next, Bell is the bigger unit. So I I know the relation I is equal to 10 times I naught. So intensity level in decibel will be whenever you see the 10 log I over n, this is called decibel. When k is equal to 1 log I over I naught, this is called bell. So this is equation in decibel, which is the smaller unit in intensity level of sound, and this is the bell is the bigger unit of intensity level of sound. So bell is a bigger unit of intensity level of sound, and decibel is a smaller unit of intensity level of sound. So I will use this numerical. I discussed this table 11.1. I told you that table 11.1 is important and this point of view, and uh, I gave you the I solved the example 11.1. Calculate the intensity level of the faintest audible sound. We know the faintest audible sound is 10 to the power minus 12. In decibel, this is in watt per square meter, but if you convert this into decibel, this is zero. We will prove it here in this example 11.1. Similarly, we listing of the in watt per square meter is 10 to the power minus 11, and in decibel it is 10 only. So we will prove this in example 11.1. And example 11.1 is 1 per 25. I use this formula 11.5 intensity level is equal to 10 log I over I naught. First of all, I replace I with 10 to the minus 12 on the top and on the bottom 10 to the minus 12. This 10 to the minus 12 will be cancelled with 10 to the minus 12. So here 1 will be left. So log I is log I 1 is 0. So 0 multiplied by 10 is 0 decibel. If you take log 1, because 10 to the minus 12 will be cancelled with 10 to the 1, here 1 will be left. So log 1 is 0, 0 multiplied by 10 is 0 decibel. So we have proved the intensity level of faintest audible sound is in decibel is 0. Next, we solve the same thing, but for rustling of leaf. As the intensity of rustling of leaf is 10 to the power minus 11, I use the same formula, 10 log I over I naught, which is in decibel. I replace I with 10 to the minus 11. So if you take 10 to the minus 12 on the top, so this is the same power will be added. Minus 11 plus 12 is 10 to the power 1. 10 to the power 1 is, if you take log 10, it will be 1. 1 multiplied by 10 is 10 decibel. So, as you know, the rustling of leaves is based in decibel is 10. Its watt is 10 is power minus 11, but in decibel it is 10. So we have proved in example 11.1 that the rustling of leaves in decibel is 10 and faintest audible sound in decibel is 0. So I hope students you understand it very well. If you don't understand, please let me know. Thank you. Memorize by heart a topic covered today, and this is your homework. Memorize by heart a topic covered today, and write down this topic once. So you go to this is your homework. So students, whenever you do your homework, please try to memorize as well as write down, because once you write down, the things become strengthened. So make sure you write down the topic as and the example we discussed. You do this. So students, if you have any questions, please let me know. Students, if you have any questions, please let me know and unmute your questions. Please raise your hand and unmute your mic to ask questions.